Hi everyone, we're going to practice adding fractions today. We're going to start fairly simple with fractions that have the same denominator. Denominator is that bottom number. It tells us how many pieces our item is cut up into. So if we have two fractions like 1/3 plus 1/3, to add those fractions all you have to do is add the numerators. 1 plus 1, numerator is that top number. 1 plus 1 is 2. Our denominator stays the same. It stays a 3 the whole way through because the size of the piece does not change. It just means I had 1/3, I added another third, so now I have two of those third size pieces. Let's look at another one like that. 4/5 plus 2/5. I'm going to add just the numerators, that top number. 4 plus 2 is 6, and my denominator stays the same. The pieces are still in fifth size pieces. You might notice this one has a numerator that's bigger than a denominator. If you were looking at how to switch an improper fraction to a mixed number, there's a different video on my channel that covers that, and that might be a good one to check out if you're seeing problems like this. What you'll notice most of the time when you're adding fractions, though, is that they do not have the same denominator. When that's the case, you have to create the same denominator, a common denominator, before they can be added, okay? So you'll notice on this one I have 2/5 and 2/10. These pieces are in fifth pieces. They'd be much bigger than these pieces, which are in tenths, okay? So before we can add them, I need them to have the same bottom number. I know I can change fifths into tenths by multiplying times 2. If you remember from creating equivalent fractions, that's exactly what we're doing. If you need a refresher on that, there's also a video on creating equivalent fractions on this channel. So to turn a 5 into a 10, my options are to multiply or divide. Since I need the number to get bigger, I'm going to multiply. I know 2 times 5 makes 10. And whatever I do to the bottom, I have to do to the top. So my 2/5, I'm doing times 2 on the top and bottom. It becomes 4/10. 4/10 is equivalent to 2/5. Now I have the same denominator, and I can add just like I did on these two problems. 4/10 plus 2/10 is 6/10. Okay? You might see a problem like this one though, where no matter what I do to the 4, there's nothing I can multiply or divide 4 by to equal 7, okay? So when that happens, I'm going to create a common denominator by multiplying times the fraction's opposite denominator. So my fraction is 2/4. I'm going to multiply it by the denominator on the other fraction. So over here the denominator is 7. I'm going to multiply this fraction, top and bottom, times 7. Remember, whatever you do to the top, you have to do to the bottom, okay? And vice versa, for the 1/7, I'm going to multiply top and bottom by the fraction, the denominator from this fraction, times 4, top and bottom. This side was times 7, the 7 came from here. This side is times 4, the 4 came from here, the opposite denominator. Now when I solve it, 7 times 2, I get 14. 7 times 4, 28. Plus 1 times 4 is 4. 7 times 4 is 28. Do you see how both of my fractions now have a 28 for the denominator? So I can add them just like we've been doing this whole time. 14 plus 4 is 18. Denominator stays the same. Let's try one more of those. This might be a good one to pause the video and try on your own, and then come back and check and see if you got the right answer. Let's try 3/8 plus 5/9. If you want to pause, this would be a good time. All right, and now we're ready to solve. 3/8, I'm going to multiply it by the denominator of the other fraction, 9. Top and bottom, whatever you do to the top, you have to do to the bottom. The 5/9, I'm going to multiply it by the denominator from this fraction, times 8. Whatever you do to the top, you have to do to the bottom. Now I'm going to solve. 9 times 3 is 27. 9 times 8 is 72. Plus 5 times 8 is 40. 9 times 8 is 72. So again, I have the same denominator, so I can add my numerators, 27 plus 40, and my denominator stays the same. All right, go ahead and give a few of these a try on your own, and let's see how you do on those with both common and unlike denominators.